high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist.
Zahid Pratap Singh, and I am from BTech Ramsarop Memorial University. And the business study that I am going to present here is basically about enterprise AI. And here we are basically trying to create two different type of machine learning model. The first one being is which is basically responsible for summarizing your text. And we have created a web app in such a way that either you can basically search about any topic that you are interested to learn about, and you are going to get a summarized version of that text. Or else, if you have some raw text in your own computer system, you can just directly copy that text and just paste it to our web app, and the web app is automatically going to summarize that for you. If that was not enough, we also have included the feature of pasting the custom web URL. Let's just say there is some website and you are basically looking for some topics and you want to learn more about it, but you are confused after seeing this website what is important topic in this and what is not. So what you can do, you can just copy that web URL and paste it in our web app, and our web app is going to just extract all the important contents from that website. And the other machine learning model that I have worked on is about image captioning. So here we have created a machine learning model, or basically a deep learning model, where on passing certain images, it is automatically going to say what is happening inside the image. That is basically to provide the caption inside the image. And this can be used in a number of ways. Like we all know, we have lots and lots of unstructured image or unlabeled image, to be more specific. So if we want to do any type of machine learning algorithm, or in general any work, we need some labeled data. So this image captioning project may be very useful for just giving label to each and every images out there that are just unlabeled. And this can also make the search engine work more efficiently, because most of the search engine work with the help of text instead of just looking at what is already inside the image. So sometimes there is, if someone basically want to spam you, he can just put the tag of horse in the image of, let's say, laptop. It is completely unreliable, but due to the tag, it will match. But with the help of this image captioning algorithm, it will just figure out what we are searching for. Is that particular thing present inside the image or not? So these are two problems that I am trying to solve. So now let's get inside our system and let's see how each and everything are basically implemented. So let's start. Okay, so let us start by looking the folder structure that we have. So just to make it more clear, I'm going to open this in VS Code, and you can basically work in any text editor, but I just preferred VS Code, and I have done this entire project in it. So first of all, what I have done is that I have created a virtual environment. So in Python, virtual environment is something that is just going to containerize the program that you are going to run, and each and everything that you are going to require to write your code, you are going to basically install in it. And the benefit of using the virtual environment is that once your project is created, you can create this requirement.txt file, which is going to contain each and every library that you have basically used to create your web app or any Python application that you are working with, so that whenever you are going to make this app run on any other device, it is smoothly going to run without causing any problem, because the problem is basically caused by the version mismatch, and this requirement.txt is going to make sure that we are working the same version. So creating the virtual environment was the first thing that I have done, and this is basically the name of my virtual environment, env, which is having all the required libraries that I'm going to use in this project. And then here is my dataset folder, and this is a dataset folder for our image captioning model that I have told. So it is basically going to contain around 8K images. So it is basically Flickr 8K dataset, which I got from Kaggle, and which is basically freely available. So this is the link of that dataset that I downloaded and used in this project. So here, let me show you some of the sample images that are basically contained here. So let me open. So here you can see this is one image, this is another image, and this is other image. So it contains around 8,000 total images. inside this folder, and then we have basically this 8K text folder, which basically contains total 8,000 captions for each and every of these images. And this image name that you are currently seeing is referred as an index, is basically just used as a primary key inside this text folder to just refer to this image. So that is about our data set. So here you can see example annotation, text image, and train image. So here we have both test and train. So here you can see these are basically the name of the JPG file we have, and just to extract the annotations, we can just extract it from the tokens. Like here we have, for every image we have its respective captions. So this was all about the image dataset that I basically used, which is basically Flickr 8K dataset. So let me just summarize this. And then here is our static folder. So the work of our static folder is to store each and everything for our web app that is static in nature. So what I meant is that when we are creating the website using Flask, we need some HTML files. So that HTML files are basically present inside this templates folder. And for this templates folder to work, it will basically be having some of the bootstrap CSS and JavaScript to make it user friendly and look more attractive to the user. And that is why we have this static folder inside which we have our images, fonts, as well as some of the bootstrap too. And inside the template folder we just have our simple HTML files. So this static and this template folder are basically required to be named in the similar way if we are going to use Flask, which I'm basically using here right now. And this Flask is basically a micro framework which is basically used to create quick and easy web app. So I'm using that. So now let's just move on and see how the text summarization is basically done and what is the main core of that text summarization, because inside this app.py we are simply going to call that particular function that is basically going to summarize it, but that is basically stored in our model.py. So what I am basically trying to do here is that first we are basically importing some of the important libraries that we basically need in order to summarize our text. So the first thing that we need to do for any text summarization or for any text algorithm to basically work is reading the articles. So the first thing that we are doing here is basically the reading the articles, and then we are basically splitting our articles on the base of the full stop. So we are just taking the entire sentences, and then what we are simply doing, we are just simply appending our sentences inside this sentence list. And here's the interesting thing that we are going to do. We are replacing anything that is not alphabet, like A to Z or capital A to Z. So this is basically a regular expression. Here we are saying which is not small a to small z and capital A to capital Z, just replace with a single space. And then we are basically splitting it to just make it word by word. And then we are simply just returning the sentences. So this is basically to read our articles. And then here we are basically using sentence similarity. So as I mentioned, we are basically going to use extractive way for our text summarization. Well, there are two ways to do text summarization. One is basically abstractive way, and one other way is extractive way. So in abstractive way, what we do, we try to recreate or rewrite the entire sentences in our own words. So it is just like how human do. We read some text and then we summarize it into our own word. But I have tried creating that model too. It was taking around 71 seconds to get executed, which was basically a lot. So I basically went with this extractive way, which was just taking 0.61 seconds. So this is way more faster than our abstractive way. And this work on the principle of sentence similarity. So I was basically searching for what will be the best way to create the extractive one. So I basically came to a blog on towards data science, where I was able to see that this can be built using something known as sentence similarity. We can just find the most similar words in our entire text, and we can from there we can basically find what all things are basically important for our summarized text. So I basically created that function for here, and here is the main thing. So here we are basically trying to make our matrix which is going to score our sentences, like which is important and how important is that particular sentence. And once that is done, the very next thing that we are simply going to do is to simply generate our summary. So till here we have the first thing we did, we read the summary, replace all unnecessary articles, then we find which sentence is basically more similar, which is basically going to be used in our build symmetric matrix. And here it is basically going to give us the score of how much value that sentence have. And then what we are simply doing, we are simply generating the summary out of it. So the first thing we are going to do, we are just simply removing any stop words. So stop words are the words like the, is, are, or, and this basically are the words that cause some problem in machine learning model, because these words are repeated too often, and these words at least have very low value than compared to any other things like any simple sentence or simple word like that. So we are basically removing our stop words, then we are simply generating the entire text. So this is the base, or you can say this is basically the main algorithm for summarizing our text. So once we have understood this model.py, so let me just simply close it. The one another thing that we are trying to do is to basically take the input of the user and then we are trying to search for it. So how that is working? So here I have a file which is basically known as webscrap.py, which is basically responsible for the web scraping, where we can basically insert a link of the user and it is going to return the entire text from that website. And it is also responsible for the search engine that we have basically implemented, where user can basically search for any topic and he can basically get the summarized version of the text. So here are some of the important libraries that I am basically importing. Import request, which is basically going to send a request to our server and get the file for us, and beautiful soup, which is basically required to just read the HTML text in more human readable format that we can basically process on inside Python. And then here we are importing regular expression. So regular expression, which is basically going to be used for our text pre-processing task, and it is very famous library and it is basically used all around. Then we are importing string, then here we are importing the model too, and then here we are importing Wikipedia. So Wikipedia is basically a module that is going to take care of the search part. So Wikipedia is basically the library in Python where we can just provide any topic to it and it is going to return the Wikipedia page of it. So as we can see that we are taking the topic as the input, we are passing it to wikipedia.page, and this is going to return the entire page about this topic. And then here we are simply taking the text in our text variable, and here we are applying our text pre-processing using the regular expression. So here we are just substituting whatever we are going to find here, we are just simply replacing with single blank. And here is the emoji pattern. So while I was working with the text on some of the website, I figured out that people are using emoji. So I basically looked on Stack Overflow and just found this way to extract or remove emoji from the text. So this is basically from the Stack Overflow where I basically found the code and I used it. And then here also we are removing any type of special characters in our text, and then again we are doing some sorts of pre-processing, and then here we are just returning the text. So this was the part of our search engine. So the search engine that we have seen where you can simply search the topic. So this was that. Now here's the get URL. So the function or the method that is basically allowing us to get the URL from the user and basically scrape the web. So it is that. So first of all, we are getting the URL. We are taking input as a URL. We are getting it inside the page variable. So request.get.url is going to get the URL. And then here we are simply checking if the response is 200. The response 200 basically means that everything went well. Then we are getting the text. So get text is the function that we are going to have a look in a while. And then here we are just printing that successfully got, and we are returning the data. But in some case, like some of the websites don't allow you to scrape the web. So in that case, we have to also handle the boundary cases, because not all websites allow us to do web scraping. So here we are simply printing error in the URL. We can just print any custom message, but for now we are simply returning that, and we are simply returning false, means we the operations was not successfully executed. And here is the get text function. So here till here we have got the entire page, but the page is in the format of HTML. So here we are creating the beautiful soup. So this is going to just convert it into more Python readable format where we can do some Python operations. And here soup.text is simply going to give the text format of the entire page without any HTML in it. So just the simple vanilla text of the entire website. And then again we are simply trying to do the text preprocessing task as we have seen above, and we are simply returning the text here. So this is the most important part, where we have basically seen two things: how we are basically implementing our search, as well as how we are basically implementing our URL web scraping function. So simply we are taking the URL, getting the text from the user, pre-processing it, and then sending it to the model. So that will come into the app.py file. So first of all, here I have imported the Flask and some of the important libraries. So here webscrap.py is the same model that I have created, so I have imported it. And the model, import model. So as we have seen in the model.py file, it is the file that is basically responsible for creating our summary using get summary function. So we have imported it. And for now, let's just move on and see how our text summarization is basically implemented, and then we can basically move forward and see how our image captioning is basically implemented. So here I am basically routing our users to the home.html, which is our default page. And then here are all the pages that are basically handled by the Flask. And when the user is basically going to hit /sort, which is basically going to be to sort in our text just to summarize it. So for that, first of all, we are getting the data. So request.form.toDict is basically going to convert our data that we basically got into the form of dictionary, so we can basically use it inside our Flask app for better processing. So here we are checking if the data that the user have basically entered is greater than 3. So if the total number of words in our sentence is greater than 3, then we are basically trying to summarize it. Because if the sentence is too small, like I love India, there's nothing to summarize in that very small text, so we are just skipping that for now. And here we are calling the webscrap.text. So as we have seen, the webscrap, so when the user tries to search something, like we have seen about cybercrime, so the first thing that we are calling here is webscrap.text, which is going to go to the Wikipedia, so to this text, and going to extract the text from the Wikipedia and return it back here inside this text variable. Then inside text summary, we are simply calling model.getSummary. So model.generate summary inside our model.py file, as we have already seen here, is going to generate the summary for us once we have given it the article. So here we have given the article, so it is going to generate the summary for us. And once the summary was generated, it is basically rendered in result.html. So HTML files we are going to have a look in a while, and we are simply passing our summarized text. My string is equal to text summary, which is going to be displayed in our web app. And if there was some error, we are simply rendering template of result.html, and we are simply saying something is missing. So we can be more specific, but for this case we have simply displayed this message, something is missing. And then here is our summarized part, where user can basically enter URL as well as the entire text. So here we are checking the same step. We are taking the data, we are checking if the method that the basically user have made is post, then we are converting the data into the form of dictionary. And here we are checking if test in data. So test is basically where user have basically provided the text data. So sorry for the name, I just used test. And then we are simply getting all the text data that the user have entered, and then we are simply saying model.generate summary. So as the user have directly passed the text to us in simple text format, so we are simply asking our model to generate summary for us inside this model.py file which we have. And then here we are simply rendering the template, and we are returning the string. But if the user have passed the URL, so this is going to hit this part, and we are going to get the URL which is in the form of data.web. So this web is basically the key which is going to have our URL, and this .get URL is going to extract all the text from that website, and that text will be stored inside this text variable. So here we have used if text. So if you remember, in our model.py file we were returning false if something was not matching. So in our web scrap.file, if something was not matching, we were simply returning false. So here we are taking if there is something, then we are simply going to scrap the data and generate the summary out of it. So if everything works perfectly well, we are returning the result, the summarized result. And if something went wrong, we are simply complaining that something is not right. So this was basically the part of our text summarization. Now let's move on to the more interesting part about the image captioning model that we have basically created. So for that, here is the image captioning.py file. So here are some of the important libraries that I have imported, which I basically used in order for image captioning model to work. And just if I try to summarize this for you, here we are basically using the concept of transfer learning. We are using a CNN model to extract the feature from the images, and then we are using an LSTM model, which is very good deep learning model for our text processing. So here we are simply passing the output of our convolutional neural networks to our LSTMs. So we are connecting two models together to perform this image captioning task. So let's have a look at the code. So first of all, let me open up my Jupyter notebook. So I basically used Kaggle. So here is the dataset that I have already shown you. So first of all, we are importing some of the libraries, then we are reading it. And here we are simply trying to look or visualize the data. How does our data look? And here we are trying to use pre-trained model, which is ResNet 50, which is very good image detection model. So here we are downloading that ResNet 50, which is basically a CNN model. So here is basically the link where we are going to download it. So it simply downloaded our ResNet model. But this ResNet model is basically made for telling what is inside the image. So what it is basically an image detection algorithm. So we have to remove the last layer from our ResNet 50. So here we have basically done that. So here we are basically removing the last layer of our ResNet model. So here you can see that it is pre-trained model, which is basically pre-trained on very large data set and it is basically trained by Google. So I cannot basically provide that much of data and that much of accuracy. So I basically use this transfer learning method of solving this problem. And then here we are doing the magic. Here we are trying to read the image, and then we are basically going to extract the feature out of the image, and we are going to store it inside this image feature dictionary. So here we are simply reading each and every images. We are reshaping it to this particular dimension, as we know that in our ResNet model, the image needs to be in certain specific dimension to enter. So it is 224, 224, and 3 basically represent for it can understand RGB colors. So it is basically a 3-dimensional array. So we are doing that. We are just simply passing our model the image, and then it is basically going to give us all the features of our image. So we are doing it image by image. So we have done it for our, so we have basically done it for 55,000 images approximately. Because of low RAM, I cannot basically train it on entire data set. So it was basically done on the lesser data set. Then we are simply checking the length of the extracted feature of the images. So it is basically 5,500. And then here we are basically working with the text data. So text data, as we have already seen, it is the data that is going to contain our entire captions for our images that we are going to train. So here we have just basically specified the path. So as I have basically done this part on the Kaggle and downloaded the notebook here, so it is basically the path of the Kaggle, not my whole system, because Kaggle provides a slightly larger RAM than my system, which basically have just 8 gigs of RAM, whereas Kaggle provides me of 12 gigs RAM, and it also provides me the GPU support for faster training our model. That's why I basically trained my model on Kaggle and downloaded it on my system. So again, back to the topic. For our caption model, we are just simply reading it, and we are basically decoding it to UTF format. And then here we are just trying to do some sort of text pre-processing task that is basically required for any machine learning model to be done. So here is the magic that we are trying to visualize. So here we are importing matplotlib, which is basically going to display our image, and we are trying to see what caption a image is. So in this case you can see that there are many captions related to the same image. So for this dog image, it is saying a dog in a snowy area, a spotted dog catching a ball in snowy field. So here we can see that for one image we have multiple captions, and all the captions are basically, most of the captions are basically given by human, so they are basically perfect. So here we are just visualizing the one, and then here is the interesting part. So here inside the text, if we are going to use LSTM, so LSTM basically, in order for LSTM to basically start working, we have to give it something at the start. So for the start, we are going to give it a start of sequence, which is going to start our LSTM model. And then we are simply pasting the modified text, and we have to tell our LSTM model that now it have finished working or finished producing the text. So for that, I am basically using the end of sequence, which is going to tell the model, yes, you have generated the entire text and nothing much is left. And then we are basically going to create the vocabulary for our word, which is going to be matched with some numerical data, because our model does not basically understand characters or words. So that is basically done here. So this is basically our captioner dictionary. So let's just move forward. So here we are going to build our generator function, and then we are specifying the batch size of our generator. So the work of our generator is to generate the caption out of our image. So here we are simply passing x in, y in. So we have basically divided our data into training and testing part. So this is basically for testing. So here we are basically using the generator to generate the image, and it is basically stored in the numpy array. So here we are just simply checking the shape, and once it is done, so now once that is done, now here we are basically ready to create our deep learning model. So here we are just importing keras. So keras is basically a deep learning library which we are going to use it in this case to generate our model. So here I basically specified the embedding size and the max length. So max length is basically going to specify like how long we want our generated text to be, or generated captions to be. So again we are basically loading each and everything that we have already done, and then here we are simply adding our models. So here as you can see, we are basically using LSTM model, and then once it is basically saved, and we are basically trying to train the model, and the optimizer that we are going to use is basically RMS prop, which is basically very good optimizer when we are basically working with the text data. And once we have basically created the overall structure of our model, we are just fitting it, and we are basically running it for 100 epochs. And once the model is basically created, we are saving our model, and we are saving the weights of our model, and we are also have to save the vocabulary, so that we can basically convert our generated numerical form captions into the text form captions. So here we have done that. So till now, till here we have basically successfully generated the model, saved the model. So now let's move on to this image caption.py file. So here we are loading the vocabulary model. So till here the vocabulary model will be loaded, and then here we are initializing the model. So the same LSTM model that we have seen, we have to initialize it, and then here we are simply loading the model. So we are basically loading the weights of the model that we have basically saved, and then we also have to use the ResNet model. So in the case if someone does not have the ResNet model already downloaded inside his folder, he have to basically run this code, which is going to download and save the ResNet model for him. But for me, I already have downloaded it, so I can basically load it using ResNet is equal to load model, and till here we have loaded our ResNet model. So now here is basically the caption image function, which is basically first going to save our image inside our local directory inside the folder of static. So here is the folder where our images are going to be saved once people upload it to our web app. So here once the image is saved, it is going to print that image is saved. So again we are doing the same pre-processing task as we have done in the creation of the model. So first we are reading the model, again we are resizing it to the size that we want, then here we are reshaping it, and once everything is basically done, we are predicting the caption of our image using our ResNet model, which is going to give the features that we need to be further processed by our LSTM model. So this is basically done till here. Now here, as we have seen, start of sequence is going to be the word that is going to start our LSTM model to generate the caption out of it. So here we are simply using that. So here we are using while TQDM. So TQDM is just going to visualize the thing that is going to happen. So it is just for visual purpose, nothing much, nothing less. And here this is basically the loop that is basically going to be responsible for generating our entire caption. So once the entire caption is basically generated, it is basically stored in our texting function. So text in is basically the list that we have created start of sequence, and here we are checking if the sequence have basically ended, then inside the final word we have got the entire text. So the final is the word that is going to store the entire caption of the image that the user have passed. So once the caption is basically done, we are simply returning the caption from here. And then let's have a look here after. So here we have basically created after function, so not a good naming, but I went with that. So the first thing that I'm going to do is basically getting the file. So whenever the user is basically uploading the file, first of all we have to get the file. So for that we can use request.files, which is responsible for handling file upload and download in our Flask web app. So first we are getting it inside our image variable, then we are simply printing in our web app image is saved. So image is saved, everything is done here. And then here we are calling our caption image. So caption is so if we see up here, from image captioning we are importing caption. So image captioning, so here is the caption function that we are basically importing, that we have already seen, which is going to save our image to our local directory and then return the caption out of the image. So inside final we would have got the caption, and then we can basically render the template saying here is the final, and here is the main function. If name underscore underscore name is equal to underscore underscore main underscore underscore, we are basically running our web app. So this was all about the Python aspects of our file, but let's just quickly see the HTML aspect of it. So here is base.html. So this is the main file, or this is you can basically say the entire template of our site that I basically used inside my website. So this is basically the base one. And then here you can see that I am basically using inheritance in order to just inherit my base.html file inside this home.html file, so that I have to basically write less code. So home.html, we can see that this is basically quick read or summarize your article. All the things that you can see here are basically seen on our home page, and we are simply ending the block. Means till here we have to basically use this entire syntax. So here we have seen block content and block end, so it will be ended by body and HTML. So this is my home.html. So now let's have the look at summarize.html. So here also we are basically inheriting from base.html, and then here we are basically asking the URL from the user as well as the text from the user. Whatever the user are basically going to choose, he is going to enter the URL from here. And here once the URL and the text are basically done, we are simply calling the action of /summarize in both the parts. So this is going to hit this /summarize function, and we are going to perform this certain steps now. So this is how we are handling our text as well as our URL. So again the next one is basically the result.html, which is again we are inheriting from our base.html, and here we are simply displaying our text, or the summarized text to be more specific. So here is basically the favicon that I basically used, which I basically got freely from the internet. So this is the code which is going to handle the image upload and visualize for the user. So here user can basically upload the image. So once the image is basically uploaded, he is going to perform this action /after, and the method is basically post, and here we are using inc type, so which is basically going to ensure that user just upload the right format data, and once user clicked submit, or predict, it is going to hit slash after, and this slash after is going to call our image capturing function, and which is in return going to give the text for the result. And once the text is basically done, it is basically displayed inside this img.html. It is again doing inheritance and such things, and it is basically opening our image and displaying our image. And let me also explain you why I have written this app.config send file max default equal to 1. So as we all know, our web browser basically do some caching. So just when we are uploading image, it is basically caching the previous image. So just to fix that problem, I have used this line, which is simply going to never cache our image. So it will be much more beneficial for us. So this was all about my project that I have basically done, and I have basically written more detailed overview about it inside the PDF that I am currently submitting. So this was it. So thanks for watching this video and listening to me.